Hi guys, this is Professor Janacek, and I want to talk about lines and curves in space. First off, the way we'll often write them is as a vector. So I've got the vector r of t is equal to, and then of course I've got the vector notation x of t, y of t, z of t. Now this can be thought of in two ways. You can call it the set of parametric equations with parameter t, so t is my variable, or you can say it's a vector valued function, so it's a vector that's defined by functions with components x, y, and z, and those components are dependent on the variable t. So again, our variable is t, the components are x, y, and z, but this is really, again, a vector that's defined by functions. So let's get into the definition. We're going to look specifically at lines and curves. They are very similar. Let's talk about lines, very basic idea. If I want the equation of the line that's through the point, we'll call it P, but it's P naught, but we'll denote it x naught, y naught, z naught. So those are the coordinates of my point. But this line is now in the direction of the vector v, which has components A, B, and C. Well, what is that? Well, the way we write the equation of a line in 3 space is R is equal to R naught plus T V naught. And this is for the vector r naught being the vector x naught, y naught, z naught for the components. Notice P is a point, but r naught, P naught is a point, but r naught is the vector. I do want to mention real quick, we'll get into describing this a bit more, but there's another way of writing this. You could also say that this is the vector x, y, z. You'll notice at the top of the page, that's kind of the notation. I can call it r. Oops. I'll say it's r, or it's the vector x, y, z. So in terms of x, y, z, I can say that this is x naught, y naught, z naught again. That's vector. So that is the same as r naught plus t, again, plus t, got that, times v. Oh, and you know what? I don't need a v naught there. There's no v naught. Sorry about that. Times vector v. And vector v, again, well, let's write it down. Vector v is a, b, c. Again, that's this bit and that bit. So they're the same, just a slightly different notation. There's yet another way to write this, and that is to write it as x naught plus at, y naught plus bt, and z naught plus ct. And so you'll notice what I've done for the x, the first coordinate, I take x naught plus t times a. And then for the second coordinate, it's y naught plus t times b. The third component is z naught plus t times c. So it's just using those vector operations, multiplying by a scalar and then adding two vectors. And for all of these, I do want to make note that our t values could be any real number. So t could pretty much be anything. Now, we initially said that this is a set of parametric equations. So you can see those parametric equations. The first component is the x equation. The second component, y equal to, there's our second equation. And the third component gives us the z value. So the parametric equations, I can write them out as equations as opposed to writing them in vector notation. I also want to mention quickly that if I want a line segment, all I do is restrict the values of the parameter for a line segment. So instead of saying t could have any value between negative infinity and positive infinity, I simply restrict that. Give some specific t values over which this can be defined, and that gives me a line segment. So let's talk briefly about what's going on here, how this really looks. We've got, we've started with a point. So notice we started with that point, P. All right, so that's the point, x, y, z. Now those x, y, and z values could possibly change with the t values. Now we've started with some very specific ones. So those are specific x naught, y naught, z naught. So those are, I have a t value, whatever that is. Okay, so I have specific numbers, but I could say describe them using functions. So there it is as a point, and then what we do is we create a vector in standard position, so it starts at the origin and goes to that point. That is the vector r of t, which is the vector x, y, z. All right, so now I've got a vector. And of course these are at a very specific point, like in this case, I could call those each one of those x naught, y naught, z naught, x naught, y naught, z naught. Very specific, but the idea here is that we actually have a whole bunch of them. So I could maybe have another point here or another point here, and we get all of these other little vectors, and so we end up with some sort of line or possibly a curve. Remember, curves are curved, lines are straight. So however you want to look at it, that's how it would be defined. They're defined the same way. Whoops. They're defined the same way. So if I have a line out here, then I just change those t values. Or if I have a curve, again, just change those t values accordingly. And so that's the idea behind lines and curves. I have all of these points described by all of these vectors. Again, these are all vectors out there going in both directions. And that describes my curve. Okay, I hope that's clear. Went too far. Okay, so that's how we describe lines and curves. So curves are really the same, but we instead of saying x, y, z, instead of making it a point, we'll usually denote it as functions. So r of t is again a vector based on functions. So that's the concept. Now I do want to mention that when you're considering a curve, the easiest way to think about it is first determine what it looks like in the xy plane. So the projection is what we call that. On the xy plane. And then we'll consider it in the z direction, then determine the behavior in the z direction. So I'll have some examples on how to work with these, but for now I just want you to understand the idea. So what is a line? Well, we start with a point. Start with a point. We define a vector on that point, and then of course we can define lots of points and lots of vectors. And again, that's the idea behind lines or curves in space. Again, the only difference really between a line is typically the x values. They're constant. It's based on just x, y, and z values. Where am I? Here it is. X, y, and z values. X, y, and z values. Here we are. However, curves, those vary a bit more. Those are based on functions. And so often we'll call that a vector valued function. All right, hope that's clear. Enjoy.